Okay, there. Can everybody hear me? Can everybody see me? Can you all see the course webpage? All right, we're in business then. So this is up because I wanted to announce that your next set of tasks are available. Your next formative assessment is due on next Monday, and you can do that now or you can wait to complete that after classes this week. Either way should be fine. And I also have released your next homework, which is based on example 2A. So we're just covering binary outcomes in the next homework. The subsequent homework 3 that's not due until after spring break is going to be on ordinal and nominal outcomes, so the second half of this lecture. So we'll be in this unit for a little while. But those things are available to you. After today, you should be able to do the first section of homework 2 and possibly the second. So you can take your time on those as you wish, or put it off until it's closer to the due date as you see fit, whichever works. Okay. And as I was saying before, homework 1, if you finished it and submitted it, you should be able to see your scores as well as which questions you got right and which questions you may not have. And if you haven't had a chance to get it done yet, that's okay. I take late work. It's not a problem. There's a 1-point penalty for each late homework. However, you earn 2 points of extra credit for doing homework 0, which translates to 2 free late homeworks. Even if you turned in all of them late, the worst that could happen to your grade is you go from an A+ being possible to only an A being possible. So I know some of you have contacted me sort of stressed out about having submitted things late. It's okay. There's nothing that you can't come back from. I just have a little bit of an incentive for, as a way of trying to keep things progressing temporally, I should say. Okay, any questions on assignments, scheduling, logistics, any of that stuff? We're good? Okay, then I will shut that down. And I'm going to pull up, this is example 2A, so we can start seeing how to get through the process of figuring out what Y is in these models for binary outcomes, how the links work, how the inverse links work, and all of that good stuff. These are data from a website that I borrowed, and I took an outcome that was a 3-category ordinal outcome and I dichotomized it to create this example. And these are fake data, indeed. So what we are predicting is whether or not someone is likely to apply to graduate school. So I recoded this data such that 0 means no, and then 1 or 2. I called that pry, because they didn't actually give labels of what this means. So, you know, like I'll probably apply to grad school. It's fine. So that's sort of an ambivalent yes in this scale. The predictors that we're looking at are undergraduate GPA, which has been centered at 3.0, so it's on a traditional 4-point scale. Whether or not at least one of their parents has a graduate degree, and whether or not they attended a private university. So that's my story. So this example only has 3 models in it: an empty model, a main effects model, and a model with a couple interaction terms. So in terms of software, within SAS, I am using Glimix. That is a procedure that fits generalized models for not just single-level data like we have, but also multi-level data. So it generalizes past just these particular models. It's one of their newer routines, and so it has more bells and whistles built into it than some of the older routines, which is why I'm using it. For the next example, I'll dip into another package because it has options that this one doesn't, but this one's going to have most of what we need. Within Stata, I am using their Logit package. With one catch, it does not use denominator degrees of freedom. So to make all of the results pertaining to significance tests equal across programs, I've shut off denominator degrees of freedom within SAS. So you'll see within the output that it says infinity for denominator degrees of freedom, which means that any t-test statistic is actually going to be a z, and any f-test statistic is actually going to be a chi-square. So I wouldn't do that ordinarily. Ordinarily, I would use denominator degrees of freedom because most of the time you're not going to have huge samples. But in this case, so that the answers are as comparable across packages as possible, That's what I'm doing. And within R, I am using the function glm in all of these models. And I believe that is within base R. I did not have to download anything to use that. Okay. Any questions on the setup of the example? All right, so then making new variables. I am recoding and renaming things so that it will be easier to follow. So I'm importing a SAS data set. This data set didn't actually have an ID variable in it, so I made one. So this is just a little trick if you hadn't seen this before. Underscore n underscore is the row number in the data set. You can actually save that as a variable, which is helpful for data that don't have IDs like these. The original outcome, apply, is what they had called it, had 3 categories. I renamed it apply 3 to differentiate it from the new outcome that I'm creating for this example, which is apply 2. So apply with 2 choices as the outcome for today, apply with 3 choices as the outcome for next week. So I am recoding apply 3 into 0 equals 0 and greater than 0 equals 1. So it's a binary outcome. They had something called PAIR-ED, which I renamed to PAIR-D for parent degree. I centered GPA at 3, and then I recoded their public school variable so that public school was the reference and private school was the alternative group. I'm trying to keep it so that all the slopes are positive, because odds ratios are difficult to interpret for negative slopes due to the difference in the scaling. So I'm trying to set this up so that all the slopes will be positive in this example. We'll see examples of negative slopes later on, but for now we'll keep it simple. And so then here are the variables we're working with today, those 4 things. Okay, any questions on that in SAS so far? And in SAS, I am going to use fake people in a few places to show you how to get predicted outcomes. So this is necessary in SAS because there's no quick and easy way to ask for predicted outcomes across a range of predictor values. So I am creating fake people. Minus 99 is their fake ID number. I have 3 levels of GPA, -1, 0, and 1, which translates into a GPA of 2, 3, or 4. So those are my low, medium, high prototypes. And then 0s or 1s for combinations of whether or not their parents have a graduate degree, and then whether or not they went to a private university. So there's 12 fake people across all of these combinations here. I then add them into my current data set. So the first 12 rows are for these fake individuals, and then the rest of the people are after that. And again, adding fake people to my data set does not hurt anything, so long as what is true. What's the one way you can screw this up? When would adding fake people cause a problem? Andrea says if you included an outcome, yes. So I'm creating fake people with respect to their predictors. I am not giving them an outcome. If they had an outcome, then they would contribute to the model, and I don't want that. All I want is for them to sit in the data set so that they can be easily given predicted values. So no outcomes in your fake people. All right, Stata folks, I am importing the Stata version of the data set, in which when I outported, is that a word? It is today. I outported it from SAS into Stata, and when export, it's proc export, there we go. It converts all the variable names to lowercase automatically. So I did the same trick to make an ID variable in Stata. I renamed apply into apply 3. I created a binary version called apply 2. I renamed and then centered GPA. And then I created the opposite of public, which is private. And then there are the labels. And then also selected cases that are complete on all of these variables, because that's what would have happened anyway. I forgot to mention that. I did that in SAS too. Okay, so Stata folks, I'm guessing you would have seen almost all of this before. Any questions on the code? Cool. Okay, R folks. So this was the data set where Sunday morning a week ago, I couldn't make this work for like 20 minutes, and I had to wait until my husband woke up, and he looked at my screen, and he figured out that these are capital letters. And that's why my code wasn't working. Because R is case sensitive. So I had typed lowercase apply here, and it didn't work. And I didn't get an error. It just didn't do anything. And that was the problem. So in the original data, apply was actually in capital letters. I have turned it into lowercase apply with a 3 on the end of it. I did the same trick to create a 2 outcome version, apply 2. The same trick to rename and then center GPA. And then the same trick to do a dummy coding scheme to reverse public into private. And then filtered the data set to only complete cases. And then I also created fake people here, although it turns out that I don't actually need to use them. But I had already created them, so I left them here. So I have a data frame called fake people that have these 3 columns in it that I can add predicted values to down the line. Okay, any questions on the R syntax? Okay, so I make a point to include this even though I know that most of you have seen a lot of this before, because I feel like that's the part that no one talks about when it comes to doing data analyses. Most of the time when I get handed a data set that I have to work with sort of from scratch, most of my time is spent setting up the data to get it exactly how I need it to do the analysis. So that part cannot be underestimated with respect to how long that can potentially take, especially if you find there are errors in the data and then you have to figure out where they came from. So anywho, so here's some descriptive statistics. So I'm using proc means in SAS, summarize in Stata, and describe in R, because I'm treating binary variables as quantitative because they're all coded 0, 1, and GPA is the only actual quantitative variable. So I did that really just for this last value right here. So I know going into these models, I'm going to try and predict apply 2. The mean of apply 2 is 0.45. So that tells me that 45% of my cases have a 1 and 55% have a 0. So the first thing that I'm going to do is make sure I can duplicate that with an empty model, because that will tell me whether or not the model is predicting the probability of getting a 0 or the probability of getting a 1. So figuring out which way is up is always step 1 in these models. So first thing here, here's my empty model. I can write it 2 different ways. I'm skipping over odds because I hate odds. And most of the time you don't see equations written in odds form. So the logit of apply equals 1 is being predicted by only a fixed intercept. So a couple things here. What's a logit? What's that part? What's a logit?
The link function.
It's a link function.
The log of the odds.
The log of the odds
Of a probability of 1.
of a probability of a 1. So I am abbreviating all of that. But keep in mind it's a link transformation that creates an outcome that is continuous. And in an empty model with no predictors, if I don't know anything else about a person, what's my best guess for their outcome? If I don't know anything else, what's my best guess for someone's outcome?
The mean.
The mean, yep. So in this case, the mean is either going to show up in my output as the probability of a 1 or a probability of a 0. Yes, sir?
Just to be sure, Lisa. So when we apply or when we use a link function, we are trying to predict an outcome without bounds, but once we use the inverse function, we can get the predicted outcome in the same scale in the outcome variable that we want to analyze. For example, in this case, probabilities.
Yes.
Okay.
Everything you said is correct. Did you hear him, Zoomers? Mostly? Okay, so he was just verifying that what we're doing is predicting an outcome in logits that is continuous and unbounded. We can back translate that linked outcome via an inverse link function into probability. And that probability will remain between 0 and 1 as it's supposed to. So this empty model in logits can be written equivalently in probability, and it looks like that. So this is one of those formulas that I would recommend you just commit to memory. Probability is e to the logit over 1 plus e to the logit. And the software will do this for you, but when you see these things, it's just easier to know that it's getting at the same thing if you can retain both of those in your head. Now, what is normally at the end of my empty model that's not here?
The error?
The error. A little e or an r, something to indicate error. It's not here because error variance is not a parameter in these models. So there is going to be no amount of residual variability that the E indicates. That goes down as we add predictors. The residual variance in this model is determined by the mean and varies by the mean. So if I predict an outcome that is a probability of 0.5, the variance around it is 0.25. The variance is the probability of a 1 times the probability of a 0. So the closer you get to a predicted probability at the ends, the less variance you will have around it. So the model's not perfect, it's just that there's no estimated variance. And in logit scaling, do you remember what the variance is? If I were to say, what is the variance in logits? The variance of the logistic distribution is what we're borrowing. Anyone? Arbitrary number, but you'll see it.
3.19?
Yeah, 3.29. It's pi squared over 3 is the variance in logits. Yep. So it will stay 3.29 as we add predictors because it cannot decrease. So a couple things here then first with SAS, and then we'll go through each of the programs. So I'm using proc limix. The data that I'm using it on is example 2. No CL print suppresses any printing that has to do with the class statement. Otherwise, it's just extra output we don't need. This method equals MSPL is how you ask for maximum likelihood in single level models. And gradient is a special option that I have not found in the other 2 programs. What it is it's going to print the partial first derivative with respect to that parameter from the likelihood. And if your estimate is the most likely estimate, like if you picture it climbing up a likelihood mountain, if it's at the top, the slope should be 0. So gradients tell you what the slope is for that parameter with respect to the likelihood. Anything that's not 0 indicates estimation problems. So with these sorts of models, you have to pay attention to whether or not the overall model has converged, as well as like the specific parameters. That's especially the case in models with random effects and link functions, but it can happen in these models as well. Next up, model. This part. Apply to is the outcome variable that we're predicting. That's the 0s and 1s. So even though we're using a link function to predict it, we have not transformed the data. The transformation happens inside the model itself. It's an empty model, so there's no variables to the right of the equal sign. Solution is not printed by default. That means please give me my answers. DDFM stands for Denominator Degrees of Freedom method. This I am setting to none so that the results match those of Stata and R. So that's only for the purposes of this example. In life, I would not do that. And then link equals logit. Can you guess what that does? Asks for us to use logits. And then dist equals binary tells it that this is a 0-1 outcome, and it's to use a Bernoulli distribution. By the way, if you forget these 2 things, like that, what do you think happens?
It is a general linear model?
It's a general linear model. Yep, it defaults to be just a regular proc GLM. That's the default if you don't specify. So, link and distribution. Now this thing. By default, when you ask for a binary outcome in Glimix, it predicts the 0, not the 1. So I switched it. I found the descending option that allows you to choose which one you predict. So we're predicting a 1 instead. And then last but not least, I have thrown an estimate statement in here that is going to ask it to spit back the intercept, which normally would not make any sense. However, I did that to get this thing right here. Can you guess what ILink stands for? Not a trick, I swear. What's ILink? You can read the comment. It requests that the logit estimate to be transformed into probability. Identity link, good guess, but no.
Are we going to get the probabilities immediately from the model?
Yes, it's inverse link, that is correct, and yes, so that we can get the logits to go into probabilities immediately without any math on our part. Yep. Inverse link. So you will see me abbreviate inverse link as unlogit. That's what I mean. Like if you go from probability to logits, that's link. To go from logits back down to probability, that's inverse link to unlogit. Okay. Any questions on that so far? So here's what we get. So I have printed the end of the iteration history because what SAS returns is -2 log likelihood down here. That's -2 times the last value in this function. So if you ever don't have enough decimals to fill 2 for the homework, then you can go up here and grab a more detailed number up there. But -2 log likelihood is height of the model times -2. So in this scaling, smaller is better. So as we add predictors to the model, we should be able to watch the -2 log likelihood value go down, which indicates that the model has improved. We can use AIC and BIC and all of these permutations thereof to do the same thing. Smaller is better. These are often used to compare non-nested models. And later on, we will look at these two values to indicate distribution fit. For binary data, there's only one choice, Bernoulli. You can't get it wrong. It's the only possibility, so we don't have to worry about that. So in my empty model, here is my parameter estimate. So the estimate itself is in logits. So the fixed intercept has returned a logit of -0.2007. In logits, what is the neutral value? Like what would a logit for a probability of 0.5 be? Do you remember? 0. So the fact that this logit is negative tells me that this is predicting a probability that is less than 0.5. This standard error goes with this estimate. So this is all in logits right here. Oh, this is supposed to be infinity. That's a copy-paste error. Let me fix it real quick. Infinity. That was from my previous version with this handout where I didn't do that, apparently. There we go. So estimate divided by standard error is my t-value, and this t-test in this case is not interesting because it's comparing whether or not our logit is different from 0, which translates to whether the mean of this variable is different than 0.5. Who cares? Gradient, this is using scientific notation, which is good. This number should be very close to 0. If it's not, that is an indication that the model is having a hard time figuring out what that estimate should be. So the last column in the SAS output is gradient rather than p-value as it typically is. And then the extra table that this estimate statement created is right here, where most of it is a packaging of the logit metrics, so the estimate, standard error, and all that. But this is the part that I did it for, right there. So it labels this new column very unhelpfully as mean. Guess what? Even when it's not an intercept, it's going to be labeled as mean. I don't know what SAS programmer thought that that was a good label, but I'd like to have a word. This is probability, and here is the standard error in probability. So the reason that I asked for this piece of output was to demonstrate how we can get it to do the probability calculations for us. So the probability of 0.45 corresponds to the mean of the cases that have a 1, so now I know which way is up. So this is an intercept and not a threshold. Okay, any questions so far? Okay, Stata folks. We are using Logit. In Stata, to get AIC and BIC, you have to ask for it. So this is a new command you probably may not have seen yet. SStat, it's a post-estimation option. Each software package uses a different N potentially in computing BIC. That matters a lot more for multi-level models than it does for single-level models, but because that's the way I typically do it, I threw it in here. So this allows us to get AIC and BIC that will match what is provided in the SAS output. And Stata gives you log likelihood. So if you want to get -2 log likelihood, such as will be the first question for every model in your homework, you'll have to multiply by -2. So the very first question for any model in your homework is going to be -2 log likelihood, because if you get that right, you have the right model with respect to its contents, the right outcome and the right predictors, the right combinations of main effects and interaction terms. So in general linear models, the right answer check was always the residual variance. In these models, I don't have residual variance. So it's going to be -2 log likelihood is the checking point for whether or not you have the right model. And I had just been multiplying this value by -2 myself to check it. But then over the weekend, I learned something. Yay me! I learned something new. How to access stored results in Stata. So right after this logit statement, if you throw in this line of code, it does the math for you. So there is, I'm trying to think of what it was. It was like list report or report list, something like that, is a way that you can see what all it stores, like under the hood when you do an analysis. And so then you just have to find the right piece of output. And so the E store of log likelihood is this number right here. So then I just added a title to it, and then I asked it to do the math for me, and that will get you the -2 log likelihood. So yes, I'm sorry, I'm just now learning how to do this, but I never bothered before. And then I thought, well, I should learn how to do this. So I'm learning how to make Stata do math on its saved results in the same way that I know how to do in SAS and R. So Stata then has the fixed intercept labeled as _CONS, which stands for constant, which is a terrible name because all of your fixed effects are constants, but whatever. And the results match. One difference, though, is that the significance tests that are labeled as T in SAS are labeled as Z here, because it doesn't have denominator degrees of freedom as an option. So this quantity is in logits. The command margins is how you get predicted outcomes. In this case, I don't have any predictor values to create predicted outcomes over, so I just asked for margins, and it spits out probabilities. So then the margins call returned this right here, which gives me the predicted probability of a 1, as well as a standard error for it, as well as a confidence interval for it. Okay. Questions on SAS or Stata? Okay, R, not bad yet. Relatively speaking, not bad. The crying happened for the next example, not this one. No, it's the next one. Just keep in mind that eventually someone will pay you because they don't want to have to figure this out for themselves. Like, this is job security at its finest right here. So we're using GLM, which does not stand for general linear model. It stands for generalized linear model, according to whoever wrote this. I'm telling it to use example 2. And then family equals binomial is all you need to do to invoke a logit link and a Bernoulli distribution. Bernoulli is a special case of binomial when there's only one trial. The model itself, apply to, is predicted by only an intercept. And again, I don't have to write the 1 here, but I do, because then I can keep track of the order of the coefficients better. The summary that you get out of this is right here. So it gives you this, which I don't have any use for. It gives you your coefficients, which I do have a use for. Note that it's in z's for the significance test, so there's no denominator degrees of freedom. It also gives you the -2 log likelihood for the empty model. Even though that's what we fit, it spits this out every time anyway. They call it the null deviance. So like the null model has nothing in it. The one for your model is right here. So it does give you -2 log likelihood directly out of R. You do not have to convert it. And it gives you AIC, but it doesn't give you BIC. I was like, okay, how do I do that? And it turns out there's just a little function you can do. So now it spits out BIC also. So this is in logits. It's that same -0.2 that we saw before. And I did not use a margins analog in this case. I just did the math myself. So coefficients is where the fixed effects are stored from your model. So I just created a new object that is the model 2, meaning I'm predicting the 2 category outcome. That's what 2 means in this case. Empty model probability is 1 over 1 plus e to the negative logit. So the formula gets shortcutted. E to the logit over 1 plus e to the logit, you can write equivalently as 1 over 1 plus e to the not logit. So change the sign, and then it works. And then I just asked it to print it, and this is what I got. Okay. Questions on any of that thus far? We're good? Okay, so just an empty model so I know which way's up. Now I know I'm predicting the 1. Let's go. So logit of the 1 is now going to be a function of a fixed intercept plus a linear slope for the effect of GPA, which is centered at 3, plus the effect of whether or not a parent has a graduate degree, plus the effect of whether or not the student went to private university. So in SAS, first off, here are the 3 new predictor variables. So they go to the right-hand side of the equal sign, much like they do in the equation. You get your fixed intercept by default. I have added this right here as an option. So note the slash here on model. All of this stuff, this whole line is a set of options for the model. I've asked for odds ratios, which are going to be how we determine effect size. So an odds ratio is going to take our slope and unlogit it, exponentiate it. Contrast is how we lump things together to get joint hypothesis tests for more than one slope at a time. So this is the analog to what used to be called the model R-square F test. If I don't have R-square, I don't have an F for it that shows up automatically. So I'm asking for one. And in particular, I'm also asking for SAS to show it to me as a chi-square rather than just an F, because chi-square is what the other programs are going to give you. So this is the joint test of whether these 3 variables work together to predict the probability of applying to graduate school. So to demonstrate then how the model generates predicted outcomes in logits and in probability, I wrote out these 12 statements. So I'm asking for predicted outcomes at low, medium, and high GPA, and then at each combination of parent degree and private school. And this is a lot of code. So an alternative is right here. So this is making use of the fake people that I put into my SAS data set to begin with. And I am asking for a new data set to be created that is called pred2 main, stored in the work library. That new data set is going to copy my existing data set and add 4 columns to the end. So pred no ilink means give me a predicted value in logits, please. So I called that column y logit. Double check if this is correct. It is actually correct. That's what I meant, y logit. Standard error no ilink is the standard error in logits. Pred ilink is the predicted probability, and then standard error ilink is the predicted probability standard error. So I've got all 4 columns that then I don't have to write all this. So in your homework, I will ask for predicted probabilities for various combinations of predictor values. You can either write it out, or you can create fake people and ask for the model to predict it directly. Your choice. And then this little proc print here is going into my saved data set and printing the predicted values just for the fake people. So where minus 99 is my ID that sets them apart. Okay. So you don't have to do any of this. This is to illustrate how the model predictions work. Okay. Questions? All right, I've got outputs, I think, in all the programs because I wanted to make sure that you could locate what we're looking for. So here's SAS. Here's my -2 log likelihood for the new model. Here is the results of my contrast statement. So note that I have a chi-square test statistic and an F test statistic. F times the number of slopes is chi-square. So you only need one or the other. In your homework, I'm going to ask for chi-squares because the other programs only give chi-squares. So it does look like we have a significant model, meaning that the 3 slopes do work together to predict probability significantly. Each individual estimate then, so my intercept, beta 0, so minus 0.5 is the predicted logit for what kind of person?
GPA of 0?
GPA of 0, which translates to a GPA of 3 on a 4-point scale, whose parents don't have a graduate degree, and who went to public university. Okay, question?
So GPA is bounded, but it's because it's a predictor, we don't have to worry about. But if we were, well, this might be an unrelated question, but like if we were trying to predict GPA, would there be another like link function we would have to use?
Yes.
And is that coming later on?
Yes.
Okay.
Yes, so GPA is obviously going to be bounded at 4, and there's going to be a lot of cases that have GPAs of 4 very close to it who would go to graduate school. We don't care about that necessarily because it's a predictor. But if it were to be an outcome, then this would be a case where I would probably trick the model into a binomial, because binomials have boundaries in the same way it uses a logit link function. It's just that then you're converting it to a continuous probability rather than one for each person. So yes, we will do those in like a month, maybe 6 weeks, something like that. It's coming. So this part of the output works exactly like you're used to, so long as you stick the word logit in every sentence. So minus 0.53 is the predicted logit for my reference person. From there, what happens to my predicted logit as a function of GPA? We can do thumbs, up or down.
Goes up.
Yeah, this goes up. Yeah.
Goes up.
So for every additional point of GPA, my logit goes up by 0.5. Likewise, if my parent has a graduate degree, my logit of applying to graduate school goes up by 1. And if I went to private university, my logit of applying to grad school goes up by 0.2. So all of these are 1 unit change language. Go ahead.
I remember that when we use categorical predictors, we tend to say that it is a mean difference, but in this case, it is what is a meaning what? Or a mean difference, or it is a logit difference? What is?
Mean logit.
Okay.
Yep. So yeah, if you want to throw some ANOVA words at this, parody, this is the mean difference in logits between people whose parents do or do not have a graduate degree. So do not is the reference, so this talks about how the logit differs for those who do relative to do not. Likewise, public is the reference, private is the one, so this is the mean difference of how private differs from public in logits. Yep, so these are all in logits. So you can interpret a positive logit as making the probability closer to 1. You can interpret a negative logit slope as making the probability closer to 0. And these are linear effects of each predictor with respect to the predicted logit. And I've got pictures coming, don't worry. Okay. Good so far? So each of these can be tested against a null hypothesis of 0. So it looks like GPA matters, parents having a graduate degree matters, going to private university doesn't matter. But that's not the end of the story. We also want to try and provide some indication of effect size. And effect size for fixed slopes are often given as odds ratios. So that's the next little chunk of the output that SAS gave to me because I asked for it right here. Now where those numbers came from, let's see if I can fit them on here. If I take the slope of GPA in logits and exponentiate it, so EXP to 0.54, that gives me my odds ratio of 1.7. So what's a neutral point on odds? Like if a predictor slope had no effect whatsoever, yeah, it would go to 1. So an odds ratio of 1 means that you have no effect. So a probability of 0.5 corresponds to an odds of 1 corresponds to a logit of 0. So the fact that this is a number for odds ratio that is greater than 1 indicates that this is a positive slope. Odds ratios range from 0 to 1 for negative slopes and from 1 to positive infinity for positive slopes. So it's a weird asymmetric metric. So it gives us odds ratios for each of the coefficients, and then it also computes confidence limits on those odds ratios. Last but not least, my predicted estimates. So the 12 statements that I wrote out to generate predicted outcomes for each of my different types of fake people. So if we look at the differences between these, for instance, my GPA slope is 0.55. The difference between this number of a GPA of 2 and a GPA of 3 is the slope, the minus 0.55. So each of these numbers is different by the same amount, the slope in logits. But if I go over here to the converted predicted probabilities, so e to this number over 1 plus e to that number corresponds to a probability of 0.25. If we look at the difference in these probabilities, they're not equal. So a linear slope of GPA in logits corresponds to a nonlinear effective GPA in predicting probability. And the same is true throughout the rest of the table. And the last line here has an example of how to screw this up. Because SAS will let you. Isn't that comforting? So I asked for the last estimate statement here. I said, can you just print the GPA slope and do the inverse link on it? And they're like, sure, cool. So here's my GPA slope in logits. That describes the difference in the predicted logit for 2 versus 3 versus 4. And the same thing is true for 2 versus 3 versus 4 for each of these kinds of people. That logit slope, if you do e to that number over 1 plus e to that number, gets you a probability of 0.63. That number means absolutely nothing. So there's an order of operations here that is critical to understand when you're trying to describe your results in probability. You start in logits. You compute a predicted logit. Then you convert that predicted logit into a predicted probability. So we start with the model to compute a predicted logit for each type of person. We then transform that predicted logit into predicted probability. You cannot transform a logit slope into a probability slope. It does not work. Okay, question?
So is the mean in this column, is the mean the value for the odds ratio or the probability?
It's a probability.
Okay.
Yep. Yeah, so the middle step that's not in the table is that you could take this logit and say e to the logit, and that becomes an odds. And then if you go one step further and take the e off, then you can get down to probability. So it's skipping over predicted odds as a middle step. Predicted odds is not typically shown. The only way that odds are used is with respect to slopes, and then these are odds ratios instead. So we haven't, let me get I have a slide on that because we haven't gotten there yet, on what an odds ratio is specifically. So for instance, for the binary predictors, the odds ratio for the effect of x1, the numerator is a ratio and the denominator is also a ratio. So the numerator is the probability of a 1 if x1 is 1 divided by the probability of a 0 if x1 is 1. All over the probability of a 1 if it's a 0 divided by the probability of a 0 if it's a 1. That's what an odds ratio is. And I hate them. I hate them with the fire of 1,000 suns. I don't know what to do with this information, honestly. And it gets even worse when you look at the scale of odds. Because, for instance, if I have a slope of 1, that corresponds to an odds of 2.72. But if my slope is minus 1, that corresponds to an odds of 0.37. So positive slopes go from 1 to positive infinity in odds. Negative slopes get shoved into the tiny interval between 0 and 1. And that just bothers me. Okay, question?
So odds can never be negative. Is that
Odds
right?
can never be negative. Yeah, a negative slope is shoved between 0 and 1 in odds.
Because it'd be like 1 over e to the whatever. Or
Odds are always positive.
yeah, but like if it's if you're going from the negative slope to odds, it's because you're with the negative exponent means it's 1 over anyway, it's making sense in my brain. But,
Yeah, so if
yeah.
if this is your slope, then e to the slope gives you this number right here.
Okay.
And it never goes below 0. So like if I were to look at these two numbers, I'd be like, oh, an odds ratio of 2.7, that's like really strong. But an odds ratio of 0.37 doesn't seem as strong to me, even though it is. So it's weird to me and I don't like it. But because odds ratios are so common and because they're very easy to get out of the software, I would recommend having a column for them in your results that have like the estimate in logits, the standard error in logits, and then the odds ratio that goes with it. Question?
Is that graphing like f of x equals e to the x?
This graph is probability on the x-axis and odds on the y-axis.
Okay.
So there's a nonlinear relationship between those two as well.
I had a question too.
Yep, go for it.
Could you describe again, could you like, you know how you like interpret sometimes what that number means? So like the estimate. Could you do that for the odds ratio?
No. I'm not trying to be difficult. The answer is no, because there's a multiplication in there. 2.72 times higher per unit is the way that people talk about that, but honestly, that makes no sense to me.
Same here. That's why I'm like, oh, finally, I can find out what the answer is.
It doesn't make any sense to me, and the other part of it is that the net result of having a slope that big depends on where you are on the probability scale. So what do I mean by that? Let me find a picture that shows what I mean by that. Right here. This is slide 8. I just wanted this picture. Too big. Here we go. This is logits on the x-axis and probability on the y-axis. So this jump in probability corresponds to a difference of 2 logits, and so does this one. So the same odds ratio has a very different effect on the predicted probability depending on where you start from. So if you're somebody who already has a really high predicted probability from your other predictors, you can't keep going as much as someone who doesn't. So this gets really tricky, especially in the presence of interaction terms. There was an article I added to your reading list that came out fairly recently about this problem. Like if you calculate something in logits and then you convert it to probability, it does not look like the same thing. So it's especially tricky when you have nonlinear effects in the context and in the context of interactions. But yeah, Andrea, I'm not trying to be difficult. I can't. Like odds I have a fundamental block in my head against them and I haven't been able to overcome it.
Do you like go take it, if you're reading something, do you take it back to logits then to interpret?
I know that if it's between 1 and if it's above 1, it's a positive slope. And I know that if it's below 1, it's a negative slope. So I know which ends up. But other words, like the idea of an odds ratio is an effect. To me, it doesn't really tell me like how strong something is. I would look at predicted probabilities and try to make a picture of those. That's how I would try to make sense of it. It's difficult. I'm catching up on the chat window. In medical literature, odds ratios is all they use. Yes, and that's why I want you to know how to get them, and maybe you'll be better at interpreting them than I am. I've tried to give you readings, and there's 2 textbooks, and all of those people are better at odds than I am. They don't make sense to me. But they don't seem to correlate in an obvious way. What doesn't correlate in an obvious way? I missed that one, sorry. Odds, negative versus positive. Yeah, they don't. So here's another reason why I'm comfortable with logits. Because if you tell me what the logit of a 1 is, I know what the logit of a 0 is. Like these are symmetric about 0 in equal magnitudes. If you tell me that I have a probability of 0.7 corresponds to an odds of 2.33, but the probability of 0.3 that goes with it corresponds to an odds of 0.43. I know, like how is that helpful information? It isn't to me, but the rest of the world has agreed that odds ratios are good, and you shall have them. Question?
But if you add the odds of 1 plus the odds of 2, like the 2.33 plus 0.429, it equals E, I think. Because E is 2.7 something.
Yeah. Okay.
But that makes it like, because like the definition of E is like if you take if you take the range of 0 to 1 and you add up all the tiny fractions in between, it ends up being E. So like I can kind of understand how odds, like it's like where are you on the E continuum?
Okay.
Yeah, but anyway, but then I just had kind of like a brain like spark that just
Yeah,
kind of went off.
I don't like odds.
Yeah.
Nathan, can you email me like writing that out so I can look at it for a little bit?
Yes. Yeah.
Thank you.
Who was that, Cass?
That was Kaylin, but I'll take it too.
Kaylin.
If you send it to me, I'll send it out to the class.
Okay.
So yeah, I have tried in the past to get better at this, and I have a block. I don't like odds. So I just don't like them. But the thing that I want to make sure that no one screws up though is what is possible for conversions and what is not possible, because that's the thing that people screw up. You can take your model and get a y-hat predicted outcome. You can exponentiate that predicted outcome and get down to odds. And then you can get down to probability as e to the logit over 1 plus e to the logit. All of this is cool. In practice, people typically skip this one because it doesn't help anything. On the predictor side, if you're talking about a slope, in the logit metric, beta 1 is the change in logit y for a 1 unit change in x1. Beta 2 is the change in logit y for a 1 unit change in x2. You can take this slope in logits and exponentiate it, and that becomes an odds ratio. But you cannot go any further into probability. You cannot take a slope and somehow make a probability out of it. It does not work. The way that you show the effect of a slope is to compute a predicted logit from the slope and then transform that predicted logit into a probability. And the difference across these probabilities will illustrate these slopes. So slopes into odds ratios, okay. You cannot go further into probability if you're talking about a slope. Okay. Even though SAS will give it to you. So it happily computed a probability out of my slope that means absolutely nothing. All right. And here's my same. This is the contents of my data set from the fake people that gave me the exact same 4 columns that my estimate statements did. So you can get it either way. Okay, are we ready to do Stata? Same model? So Stata people, much less typing for you. Although, one thing I learned the hard way, you have to run the model twice to get odds ratios. So here's my model. Logit predicting apply to from my 3 quantitatively treated predictors. Here's my AIC and BIC. This thing right here, this test statement, is going to give me a multivariate walled test of the model. So that's going to generate a 3-slope chi-square that corresponds to what we would typically think of as the model F-test for the R-square. Margins, I've got 2 different margins because they do 2 different things. So this loop, it's minimum value of the predictor, increments of the predictor in the middle, and then maximum value. That piece of code right there gives me 12 different predictions. I can do logit, yes, that's what I have down here. So I'm asking for the same model twice because the first time I'm going to get logit coefficients and the second time I'm going to get odds ratio coefficients. I have not found a way to get them both in the same shot. It's either or. Yeah, no worries. Either or, ba-doom-tsh. I get a rim shot for that because it's or is what you type to get odds ratios. Either or. Get it? No? Okay, come on. I'm stats funny. I'm never going to make a living as a stand-up comedian, but like relative to the going rate for statisticians, I'm a riot. Either or. Anyway, so my margins here, predict XB says, hey, can you put those in logits, please? And no predict XB is like, can you put them in probabilities? So probability is the default for margins from this routine. And then, can you put them in odds ratios? No, you have to add comma or, and then you get it. So here are the results from Stata. It gives you a likelihood ratio test of your model instead of a wald test. So that number will be close, but not the same as the chi-square that we asked for specifically. This is a different way of doing a model comparison. It's doing a -2 log likelihood difference against an empty model. That's what that is doing for you. And here is log likelihood times -2 if you want to turn it into -2 log likelihood. Here are my slopes in logits. So no, it's labeled as coefficient. You just have to know that that means it's in logits. And the fixed intercept is always last, but otherwise the results are exactly the same as they were in SAS. Here's my AIC and BIC. Here is the chi-square that I asked for, lumping all three slopes together. So that's the multivariate wald test of my model. Here are the predicted logits out of margins, and then here are the corresponding predicted probabilities. And what is not in this output, because it was already going to be long enough, is a giant table that tells you what the hell 1 through 12 refers to. Because this is not helpful. It has to do with how you wrote the order within that section. So there's an extra step where you have to try and convert it. And then here's the odds ratios version. If you do the comma OR, then this column is labeled odds ratio to help you out. And then this is a standard error for that odds ratio and a confidence interval for that odds ratio. So they make it pretty easy. Okay. Questions from the Stata folks? All right, R. There you go. Much coding. So here's my new model. I have GPA 3, parent degree, and private school thrown in. I want the results. I want the BIC. It doesn't give you odds ratios, so you got to ask for them. So I threw the coefficients into the model into an object called odds ratios, and then I glued that result to the same result for getting confidence intervals for the odds ratios. And so this combination right here gives me odds ratios and confidence intervals for it. And no, I absolutely did not come up with this on my own. I found it on a web page somewhere. Probably the same web page that I stole the data from, to be honest. Here is the multivariate wald test of the model. So this is GLHT, the same as you just got done using in your first homework. It works exactly the same way. You have options for whether you want to get an F test out of it or whether you want to get a chi-square test. So just like in SAS, it gives you both if you'd like. We'll do chi-squares in this class. That way everything matches across programs. So the default output then you get is right here. There's my -2 log likelihood and my AIC and the BIC. These are the odds ratios, and I have a note out here that these confidence intervals do not match what's in Stata and SAS. It appears to be doing some kind of resampling something on its own to find them, which explains why they don't match, because you would have to know what the random seed is for the resampling to be able to get it exactly right. So practically speaking, what that means is that in your homework, I will never ask for a confidence interval of an odds ratio, because I will not get the same answer across the 3 programs. So me working through all of your homeworks is actually very instructive to make sure that I can, in fact, get the right answers from all 3 programs, because I won't ask any questions that I can't make it work. But the odds ratios themselves do work. They are just e to the that number printed down here. Here is my multivariate wall test. So there's my chi-square of 18 that tests the model. How different are they? Different to at least 2 decimal places. Different enough to not have the correct answer with a margin of rounding. So, yep. Then we do predictions. So this is the new thing. Solomon, are you here? Giving you a shout out. Yes, I see your face. There you go. He sent this to me, and I actually found it on my own the day before, but he helped me figure out how to use it. So there is a new R function called prediction that's within margins, and it works like Stata. So the at list in here is asking for predicted outcomes as a function of this minimum value and this maximum value. You can also use a sequence thing to do increments of by as an analog. Type equals link means put it in logits, please. And type equals response means put it in probability. So I asked for 2 separate objects, predictions in logits and predictions in probabilities. And those are right here. So it gives you standard errors and confidence intervals for the predicted logits and the predicted probabilities. I'm not sure if these match or not, but I would hope they do. I can't guarantee they always will. Let's put it that way. Okay, and I don't have pictures yet because I did a picture for the interaction model instead. Okay. So, big picture summary. We're predicting binary outcomes. But in order for a linear model to have slopes that keep going, we can't predict binary outcomes directly. We predict them indirectly through logits. So all the output that you get to start with, everything's in logits. You can take your slopes and unlogit them into odds ratios to get effect sizes. So e to the logit for a slope. But you cannot unlogit your slopes into probabilities. For predicted outcomes, you can ask for them to be predicted in logits. You can then transform those predicted logits into predicted odds if you want to. But more usefully, you can transform predicted logits down into predicted probabilities. And all of the packages have very relatively easy ways to do that built in. Relatively easy. Okay. How are we doing? Okay. Questions or any of that you want to go back over with respect to the coding or the results? So what's coming then on Thursday is one more model that has interaction terms. But guess what? It's exactly what you already know how to do. We get simple slopes, and then we turn those simple slopes and logits into simple odds ratios. And eventually, I got pictures. Here they are. So pictures in predicted logits and predictors in predicted probabilities. And if you're looking at these and you're thinking, did she make those in Excel? Yes, I did. And I'm not ashamed of it. So within your download packet for this unit, I have Excel spreadsheets. So there is one important benefit to making figures in Excel that they don't tell you about that you should be aware of, and that's, are you going to have collaborators? And do all of your collaborators make their pictures in R or Stata or SAS, or do some of them not know how to use those programs? If you're going to be working with collaborators who might need to take a figure that you make and change the labels or change the colors or change whatever, hand them an Excel file. Because then they can do whatever they need to the figure, and you don't have to be the one tweaking it for every new possibility. So there's an important reason why Excel is useful, is because it translates across multiple platforms and investigators regardless of their preferences for stats software. So I did make this in Excel, and I'm not ashamed. All right.
Lisa?
Yeah.
When we use qualitative predictors with more than one category or more than two categories, how can we interpret the effect sizes or the odds ratios between categories?
So question was like, if this variable right here had 3 categories instead,
Yeah, for example, yes.
then you got to turn it into 2 different slopes,
Exactly.
the same as you did for golf.
We can compare it directly. But I mean the effect sizes, the odds ratios.
Yes, so you would have a predicted mean difference in logits between each group relative to the reference group. You can then take those slopes to convey the mean differences and turn them into odds ratios.
And then compare the odds ratios.
The comparison has to be in logits for it to be valid. So that's an important point, actually. All the significance tests that you're doing are in logits.
Okay.
So you could figure out what are the pairwise comparisons between groups that you're interested in. Each of those comparisons is its own slope in logits. If you want to know if there are different differences, you would compare the slopes in logits.
Okay.
And you can compute odds ratios out of the slopes if you want to, but the significance tests happen in logits. Okay, then it's 1:45, which means I say goodbye. It's Tuesday, so I say see you Thursday. Let me know if you need anything. Thanks for coming. Bye, folks. Bye, Roomers. Bye, Zoomers.
So I have just